Hello everyone, welcome to my YouTube channel. Today we will be going through constructing a binary search tree from tree traversal. So without further ado, let's get into this. Hello everyone. Now I will be explaining about the binary search tree, which is also known as BST. So BST has simply in BST the left subtree node values are lesser than the root node values, and the right subtree node values are greater than the root node's value. So this line I will be explaining here. So this is the root node, and this is the left subtree node, and this is the right subtree node. So root node is 4 and left subtree node is 2. So which is 4 is greater and 2 is lesser. So these side left subtree values are always 1, 2, 3, which is lesser than 4, and right subtree values 6, 5, 7. These values are greater than the root subtree nodes. So simply this is what has been explained here. So left subtree node values are lesser than root, and right subtree values are greater than the root. So this one and this one is similar. And what are the advantages of BST is that enables efficient searching and insertion and deletion. So this is all about an introduction for BST, also known as binary search tree. Tree traversal. When it comes to tree traversal, there are three main tree traversal: Inorder, Preorder and Postorder tree traversals. So let's go into one by one. So Inorder tree traversal is simply we first visit the left node. So in Inorder tree traversal, this is the left node. We first visit this, and then we visit the root node, and afterwards the right node. So this is how the structure of Inorder tree traversal works. This is how Inorder tree traverse happens. And Preorder, first we visit the node first in the Preorder traversal, and then the left side node, and afterwards only the right side. So this is how the Preorder traversal happens. And the Postorder, in Postorder, first we visit the left side, and then the right side, and afterwards only we visit the root node. This is how the Postorder traversal occurs. So in tree traversal, it's more about the structure of how the nodes traverse. Tree traversal. When it comes to tree, so tree traversal, as I explained you, so about understanding the structure and how the traversal occurs. So this helps us to reconstruct a binary tree if we want. So these are the advantages of tree traversal and the main usages. So tree traversal, now we will be understanding the key ideas. So using Inorder plus Preorder traversals, we can rebuild the original tree again. And the other point is that it explains the first element of the Preorder is always the root node. So and the Inorder, the third point explains Inorder is split into left and right subtrees. So this is all about the key idea. Now we are going to reconstruct original tree using these two sequences. We have been given an Inorder sequence and Preorder sequence. So now we will be reconstructing our original tree. First we have to find the root of the Preorder. This is the first step. So always the root of the Preorder is always the first element. So this one. In the Inorder, the second step is in the Inorder, we have to split to the left side node tree and the right. So 4, 5 is the left side, and 6 to we are going to reconstruct original tree using these two sequences. We have been given an in-order sequence and pre-order sequences. Two sequences are given. So now using these two sequences, we are going to reconstruct the original tree. So in that, first we will be having the pre-order. We will be circling this because always the root node comes first in the pre-order, and we will be marking two lines here for in order, and afterwards now we will be breaking this part. Is explained simply about we have been broken to left subtree and right subtree in the in-order concept as per the in-order concept. So the left subtree is this 4 to 5, so 4 to 5 is here. So and the right subtree is 6, 3, 7 for in-order, so 6, 3, 7 is here as you can see. And then so from here we have to consider then the left subtree. So in left subtree already we have 1, and afterwards the 2 is the 2 here, this 2 is there. So 4 and 5 should come here. So I will explain again. So this one comes from here in the in-order part. This is the in-order section. So here the 2 the one is diagram is made up of this one comes from here, and this 2 has been further divided, and then the remaining 4 and 5 has come here. For the right side the same thing, this whole thing is came here similarly. So the same thing 1, 2, 4, 5 is there. And the other part, the right subtree has been drawn here. The 3, this 3 has been coming here, and we have been included 6 and 7 over here. So this is how it's made up of. And using pre-order, we just consider the first node. So we have been considered the first node, which is not that useful. So here 2 is here, and the first node of the right pre-order is 3. So these 3 are there here. I mean, like the first left pre-order first node is there 2, and the right pre-order first node is 3. So in the pre-order we always consider the first node. So this is what has been explained here. And finally we are going to create the original tree, reconstruct the original tree. So 1. And then we will be going to 3, afterwards 4, 5, 6. So this is the reconstruction of the original tree. So similar answer is here. So this is all about the reconstruction, and pre-order sequences are given. So now using these two sequences, we are going to reconstruct the original tree. So in that, first we will be having the pre. Now that we have understood the theory really well, now let's implement the code using Java programming language to understand the logic behind the binary search tree using traversal. So here, as you all can see in this code file, I have created two code files, node.java and construct.bst.java. First of all, I will be explaining the node.java. So when we open this up, we can really understand that this node.java, this file defines the structure of a tree node. Each node stores 3 things: the value, a reference to the left child, and a reference to the right child. So specifically in data node left comma right, this explains the thing like each node stores the 3 things: the value, a reference to the left child, and a reference to the right child. So this is what this two code lines explain. And when it comes to here, this is the constructor that initializes the node with a value and sets left and right child to null. So this is all about this portion of the code. A construct had been created and initialization has been done. And now let's get into the construct bst.java file and its logic behind it. So first things first, this construct, we have to understand construct bst.java. Why do we create such a file? So main use case of this is that this file contains the logic to reconstruct the binary tree using Inorder and Preorder Traversal. So that's why it is. And when it comes to static in preorder equals 0, this line specifically, we have to understand this file is a main use case is that this variable keeps track of which preorder elements is currently being used as the root. So likewise, because of that, and when we go into node root equal new node preorder plus plus, so this code line, it's like we take the new element from the preorder and create the root node. So for that, and int index equals search in order in start int end in end root dot data. This code line is that we first the position of this root is the Inorder traversal. We find here the position of the root in the Inorder traversal, and this root dot left build tree and the root dot right build tree is like we recursively build the left subtree first and then the right subtree. So first the left subtree recursively we build and the right subtree then we build. So that's what this line explains. And let's get into the public static void main method. In the main method, it's like we provide the Inorder and Preorder arrays and call the build tree function. So finally, we print the Inorder traversal to verify the correctness. So let's run and see. So it has been constructed as correctly as we discussed in the whiteboard 4251637. The tree has been reconstructed as it is. Now that we have understood the theory really well, now let's implement the code using Java programming language to understand the logic behind the binary search tree using traversal. So here, as you all can see in this code file, I have created two code files, node.java. So in conclusion, BSD can be reconstructed using traversal data, and preorder gives root, and Inorder builds tree, and recursive method builds full tree. So in conclusion, this is all it sums up. So thank you guys for listening, and this is all about the binary search tree from Traversal. So I hope I have given you a clear and concise insight of this topic. So hope you all to see in other video. Until then, thank you.